All right, so I got 3 limit problems today. The first one says the limit as x approaches -4 of the polynomial x squared plus 5x plus 4 over the polynomial x squared plus 3x minus 4. This is a rational function. Unfortunately, if you plug -4 into the denominator, you get 0. So the first thing you should do is, I put up a little graph over here, but you don't need it. First thing I would do is factor. And I get x plus 4 times x plus 1 over x plus 4 times x minus 1. And I notice right away that the asymptote is positive 1, which you can see on my calculator. Right there's the asymptote. And by the way, the left hand and the right hand aren't the same. They're both negative infinity, positive infinity on that, if you cared. But what we asked about is 4. And when you look at the graph at -4, 1, 2, it looks like it exists, but actually it's a hole, isn't it? Because these cancel. And if I plug -4 in now, I get -4 plus 1, which is -3. -4 minus 1, -5. The answer is 3/5. I know my graph's a little off there, but you know my pen. But there it is at 3/5. So that's the limit of this function. Does it exist? Is there a value of f of -4? No, there's not. F of -4 does not exist. All right? But there is a limit, and there is a removable discontinuity at that point. All right, the second one today. I'm not even going to graph. You know why? I think we learned that we can do direct substitution when the bottom's not 0. And I plug 0 in, so the answer is -4/3. Guys, don't factor.
Dang it. You can't factor the bottom.
You can't factor the bottom anyway, right? You could have factored the numerator, but it doesn't do you any good. The only place that you'd be worried about this is where this equals 0. I don't know where it equals 0. It's some weird radical, I think. Point is, I don't care. The answer is -4/3. Now, on number 3, the denominator is 0, right? So, can't factor. So let's expand. That's where this starts. All right, there's a couple ways to do this problem for expansion. First of all, I think of Pascal's triangle, right? So if I have x plus y cubed, it's x cubed plus 3x squared y plus 3xy squared plus y cubed. And this is Pascal's triangle for binomial expansion. And in this case, x is 2 and y is h. So I can write this out knowing that as 8 plus 12h, right? Oh, wait a minute. Oh, wait a minute. I'm wrong. It's not 0.
It's 20.
I think it is. Yep.
Yeah, it is.
All right. Plus, again, x is 2, so I get 6h squared plus h cubed minus 8 all over h when you get done expanding it.
Wait, you have a minus?
You already did the minus 8
you
and
did
the 8.
Oh, I forgot
No,
the
you
minus
have to
8
have a
up
minus.
here.
The minus 8 is right here. The 8 is from,
It's not 20.
okay,
It's
I cancel.
Yeah, it's 12.
It's 12? Okay.
I was
I got 12.
So everybody, the 8's cancel, and I've told you this, I'm not going to factor h's anymore because we're smart people. And now, can I let h go to 0? Yes, I can.
Yeah.
And I get 8, I get this limit is 12. Now, everybody, I'm going to copy this to the next page. We're going to talk about this graph for a second, okay? Does everybody see that this is a tangent line?
Yeah.
All right, so now I want to talk about what function it is.
Wait, so I have a question.
Yes. Not always, but when the h is on the bottom like this, the answer is yes. All right. So everybody, does anybody see this? If I do it now. And now we know that this is a tangent line because we talked about it a little bit at least. Well, everybody, I think a is 2. Does everybody see why a is 2? And what's the function? X cubed. So a is 2. F of x is x cubed. Now, that's one of our parent functions. We like this function. We can picture it going through the origin. Can you guys picture that at 2, that would be a very steep line. So a slope of 12 makes complete sense. You don't like my picture? It's good enough for calculus students. You guys are good at this. All right, so keep practicing. These are limits. These are warm-up problems. Understand where they come from.